So now we're going to be applying this to the write-up of this. And magnetism is produced by a current-carrying wire. What's the initial direction of the red tip of the compass needle? This, again, if you remember, what direction was the compass pointing? This points to Earth's magnetic north. And if you remember, I brought in a magnet to show what's happening to the compass. The magnetic field of the magnet moves the compass. So the compass responds to the magnetic field that's coming from the magnet. What's the direction of the red tip of the compass needle with the electric current traveling through the wire? Well, if you draw the top of this again, with the wire coming underneath, the wire coming through like this. Remember, the current was coming from underneath, so it was moving up like this. We applied the first right-hand rule, and therefore the magnetic field is going to be going in this direction around. Direction of the red tip of the compass needle with the electric current traveling through the wire. So if we put the compass right here, it's going to be pointing to the north. If we put the compass here, it would be traveling to the south. We can do this part right here as this part of the lab. So we're going to have our wire like this. And the current is actually running in this direction. So since the current is running in this direction like this, okay, my thumb is the current, and that means the magnetic field is going to be in this direction. So if I'm above the wire, and I put this compass right here, the compass is going to be pointing to the top. If I put it underneath, the compass will then be pointed towards the bottom. That's because if the current's running in this direction, my thumb is a representation of the direction of the current, and this is going to be the direction of the magnetic field going over. So if it's going over, the magnetic field north is going to align with that, and as it comes down this way, it's going to be aligning itself to this. So the effect on the compass needle by the horizontal current-carrying wire, what happens if the current is reversed? Of course, if the currents are reversed, you'll have the opposite effect. But if you have your wire like this going from left to right, and the current is running in this direction, again, we had the current running in that direction. So the current running in this direction, if you have the top and you have the bottom, what's going to happen is the magnetic field created will go over and that will come under. So since it's going over, the compass will be pointed up in this direction, and on the underside it'll be pointed down as the compass aligns itself to the magnetic field as it comes underneath and towards us.